This time, given the name, you write the formula. This uses some math. And for this part, you do need to show your work on some paper when you take the test so that you will upload that paper just like you did with the last assignment. And that will be part of your test grade to kind of prove that you're doing the work and not just looking online for answers. Here, the first step is to write the symbol with the charges and then see if they add up to 0. So I'm going to say sodium. I'm looking at this one here. Sodium, I know that's Na. And then hydroxide. Hydroxide is unique. It's the polyatomic that ends with "ide." So I'm going to write the charge of sodium. And I already remember it, but sodium's here, that's +1. And hydroxide, if I try to look for it on the table, I won't find it, but because it's a team, it's OH -1. So I'm going to write Na +1 and OH in a team -1. And then the second step is to list them until they add up to 0. And +1 and -1 do add up to 0, so I don't need to continue with any listing. And now I just count how many atoms there are and use subscripts to write the formula. So 1 Na, but when it's 1 we don't write a subscript, and 1 OH team. So I'm going to show the team in the parenthesis, but I don't need anything out of the parenthesis because it has 1 team. This one, potassium is K. Now sulfide, that means it's off the periodic table usually. Only hydroxide was special that way. So sulfide was sulfur. So I need to find the charges. I'm going to look for K and S. All right, here's K. So K is a +1, sorry. And over on the other side is S, and that's a -2. Remember, positive always comes first, so that will help you when you're looking for them. So first step, write the symbols with charges. Second step, list until they add up to 0. Do they add up to 0? No, +1 and -2 are not, they do not add up to 0. So I need more positives to start to balance out that negative. Now do they add up to 0? +1 + 1 is +1, +2, plus -2 is 0, yes. So now I count the atoms and write the formula. So there are 2 K atoms here, K2, and only 1 S, K2S. That means it takes 2 potassium for every 1 sulfur to make everybody stable. That's the lowest ratio. Lithium nitrate. Lithium is Li. And now notice 8. That 8 ending is a hint that this is a polyatomic ion. I'm going to highlight that. That 8 ending is a clue. So I need to find the charge of lithium, and I need to find out what is nitrate and its charge. So up here, remember the lithium is going to be a +1 because it came first, so I'm finding lithium again. Here it is, +1. And now nitrate is going to be one of my polyatomic ions, and I see it here, nitrate. NO3 with a -1. So sodium was a +1, and NO3 is the team. It's a team of 1 N and 3 O's, and it's a -1. Now, do they add up to 0? Yes, they do. So now I'm done listing because they already add up to 0. It's a 1-to-1 ratio, and I show that like this. Magnesium nitrate. Oh, there's that 8 again. So that means that's a polyatomic. Magnesium's a an Mg, and I need to get the charges. Magnesium is here, +2. And nitrate, again, was the -1, same one as last time. So this time, because it's a +2 -1, they do not add up to 0 yet. So I'm going to list, I need more of the -1. Now they do add up to 0. +2 and -1 means they add up to 0. So Mg, I'm counting now, there's only one Mg written up above, but there are 2 NO3 teams. So I write the team just the same way in the parenthesis as above. I didn't change anything yet, but now I'm going to put the little 2 out here so that you can see that there's 2 of that whole team. Just like in math, a parenthesis means it applies to everything in that. So it means 2 of the whole team. All right, aluminum carbonate. Ooh, an 8 again. The 8 ending I'm highlighting because that's a polyatomic ion. So Al first is going to be my positive one. And then carbonate. I'm going to look them up. Aluminum, Al. And that's in my +3 group. And carbonate, Ate, it means I'm over here on this polyatomic ion chart, and here it is. So the team is CO3 with a -2. So 3 positive and CO3, 2 negative. Now they don't add up to 0, +3 and -2. Whenever you have the 3 against 2, that's going to be the most listing that you have to do. So I'm going to start with the negative because it's less. I need more negative to start to balance this out. But now it's a +3 and a -4 if you add these up. So now I'm going to add another positive. Now together these are +6, and this was still the -4, so they still don't add up. So now since I need more negative again, I'm going to add another one of those. So you see how sometimes it really does turn into a list. And now +6 on this side, 2, 4, 6, -2, 4, 6, -6 on this side. Now they add up to 0. So I'm going to count. It takes 2 ALs, so Al2, and 1, I'm going to highlight for a sec, 1, 2, 3 CO3s. To show that, we go CO3 inside. Notice that still says the same thing as the team always says, but the 3 on the outside tells me there's 3 of those. Notice there's no charges in the formula, only when we're showing our work above. Okay, I see another 8 ending here. So calcium carbonate. Let's look for calcium. Calcium's here. That's a +2. And carbonate, we just did, that's the CO3 with the -2. +2 and CO3 -2. Do they add up to 0? Yes. So now I know it's just one of each. It's a 1-to-1 ratio. Oops. So inside of the parenthesis, it still says CO3 because that's the team. but we don't need a 1 outside the parenthesis. A 1 is assumed if we don't see any subscript. So that's the formula. Ammonium nitride. So this time the nitride, the "ide" ending, means it's from the periodic table, but ammonium is a good one to memorize because it sounds like an element, but you'll look and look all day long and you won't find ammonium here because it's our only polyatomic positive ion. So it's the only positive one that's polyatomic. So ammonium is NH4 plus 1. And nitride, you might be able to guess without looking at the chart, nitride is nitrogen. But let's look here in case you didn't know that we would go way up here. Nitride is nitrogen. So back to our table, we got to find nitrogen, and there it is. So remember, all of these are going to end with "ide" when they're in compounds. So nitride, oxide. So nitride is a -3. Do they add up to 0? No. So I need more positive because 3, there's more negative here. I got to balance. Now they add up to 0. I took 3 of those. I guess I forgot my parentheses here. We don't want to forget that. So 3 of those. So to show that in my formula, NH4, 3, and then N. Only one N. Next one. Magnesium hydroxide. Here's an "ide" ending, but if you memorize hydroxide, that will help you to know that's one of our polyatomics. So here's Mg and then hydroxide. Mg is this one, +2. And hydroxide, yeah, all of these end with "ide", but remember that's the unusual one. It ends with "ide". It's over here, OH -1. Oops, guess I'm getting ahead of myself. So I have a +2 here and an OH -1. Do they add up to 0? No. So since I have only -1 against a +2, I'm going to make another OH here. Now do they add up to 0? Yes. So I'm going to count 1 Mg and 1, 2 OH. I put the parenthesis around the team and the 2 on the outside. Because remember that 2 means there's 2 of the whole team. That's the formula. Boron chloride. Boron is from the periodic table, that's B. And chloride means this is Cl, it used to be chlorine from the periodic table. So I'm going to go get the charges. B is here, so it's a +3. And Cl, chloride, is here, and that's a -1. So +3, -1. Do they add up to 0? No. So I need more negative, so another one. +3, -1, -1, not yet. Now they do. So it's going to be, I'm counting B, Cl3. There's your worksheet. Good job, everyone.